Okay. Any questions from homework? Yeah.
I had section 7.1, number 15. It's in the rational expression.
Oh.
The first part is like a regular factoring part.
We haven't got into that yet.
Yeah, I know. The second part is okay, but there's a first part in there that would just do anyway, normally, like right now anyway. You know what I mean?
No.
You just do the problem 2t plus 11t minus 6.
Oh, I see what you mean.
Yeah.
So how to factor this? Yeah, we certainly can talk about that. And the teacher just say, "Could you help me factor this?" Don't even tell me where it's from. All right. So this does come from a later section, but it's the whole next chapter, and actually the last part of chapter 6 and the entire part, chapter 7. Everything's going to be based on factoring. Right? So it's insane. Once you learn how to factor, it opens the door for all these kind of problems that you can finally do. So the bad part about it is if you're not able to factor, you will not be able to do basically anything for the next few days, which really sucks. It pretty much tells you how important it is that you get this factoring down. It's not just a one-section deal where you're like, I just don't have to worry about that problem. No, there's going to be many, many problems with factoring in it. How do I do this kind of problem here? Yeah, there's no GCF. I can't take a 2 out. Always look for that. If I can take that 2 out, then it makes the problem a lot easier. But I can't, so I've got to take it into account. Factors of negative 12 that make 11. They're off by 1. Do you see that? So it's got to be 12 and 1. And which one's got to be? 12 is positive, so 1 is negative. Good so far?
And why did you know right away that the 12 is positive?
Because the middle term is plus. So the bigger one's got to be positive. Cool. So don't look at... It's not just a way of looking at it. It's just that there's not like a ton of stuff to memorize with the signs. The signs help you. There's not like a lot to memorize. You just go, oh, that's positive, so the bigger it's got to be positive. I mean, they help you. There's not a ton to memorize because of them. And what do I do with those two numbers? Yeah, rewrite this. So this is still here. Rewrite 11t as 12t minus t. Or you put the minus 1 there if you want to, sure. Group it. What comes out of these two? 2t. What's left? Good, t plus 6. To make that a positive t like it has to be, use this guy as a hint. It's got to be the same there. I've got to take out negative 1. Yeah, everything in there changes signs now. And of course, what can you take out of there?
2t minus...
Yeah, I know I'm on the right track because these are the same. So the t plus 6, 2t minus 1.
I don't know why I'm in the habit of thinking that you need to find two numbers that add to the 11 and multiply to negative 6. What am I doing there?
Add to be... Oh, I see. You're not going totally wrong. It's just the fact that this is not a 1. If that was a 1, that's all you have to worry about.
Okay. All right.
In fact, I mean, if I have a problem like this here, what is 1 times 15? 15. So we always do this multiplying thing. It's just that if there's a 1 there, it doesn't really change anything. That's why it's easier. If there's not a 1 there, it changes stuff. Oh, crap. Yeah.
You're going to have the same problem with number 15 from section 6.3.
Yeah, I have a hard time with that.
Yeah, I see it, but I see how it's pretty possible, but I can't.
You guys good with that?
Yeah.
Spend forever on that part.
Sorry, buddy. That's all it takes is that 2 messing you up. 15. Yeah?
Yeah.
This is section 6.3. what did you do first there?
I took out 2.
I love it. So there's a GCF. I always take that GCF out because either it's the only thing you can do or it makes it easier to do. In this case, it's going to make my number smaller, which is always appreciated. Take a 2 out. 3x squared. 5x minus 2. This is very similar to the last problem because not a 1 out front, so what do I have to do first? Yeah, 3 times negative 2 is,
-2.
and I factors in negative 6 that make negative 5. That's 1 off from that. So it's going to be 6 and 1.
Yeah, see, I did all that, but now I can't do it. I have that, I still can't make it happen.
I got you. So which one's got to be negative?
6.
The 6. So the 2 comes for the ride. You rewrite everything except this now. It's minus 6x plus 1x.
Oh,
And then plus, that's the only thing I did wrong so far.
That's all it takes.
But
That is all it takes. Yeah.
When you put the 6 out, and you start factoring or doing, right? You just did that step, I just want to make sure I don't take that step out. You did that because of the 6 in the front, because again,
No. I took a 2 out, and now 3 times negative 2 is negative 6, and then factor that to make negative 5. Yeah. Yeah.
I think I get confused because you have to carry down the x, which is 6 and
Yes. These still have to, they have to add up to be this. So if you just put that there, those don't make 5x.
but what about negative 6 and 3?
Say again?
What about just putting 1x? Like, just,
Plus-
negative 6x and then plus 1.
Well, then they're not like terms. They can't make negative 5x. So they each have to be there. Now, so just because this kind of came up, I really don't like doing it this way, and I don't think, I kind of get the feel that most of you guys probably wouldn't like this way either. But the way I was taught this a million years ago was to take 3x squared, the whole damn thing. And then when you factor this, it's x and x for x squared. So I don't know, maybe you do like that. I always just like looking at the numbers and just knowing it's the coefficients of the middle dude. But if that's better somehow, maybe it is, I don't know. I've certainly been wrong before. So if you like that better, sure, why not? But that middle term has got to have that, whatever that is, it's got to be there and there. It's the only way that it would actually combine back together to make this. I just find the coefficients that'll make it work. Yeah.
Alright, and that 1 is positive because it's a positive on the 2 over there. Like, it's negative 6 and 1.
It's got to be
So
negative
no matter
6 and
what-
positive 1.
No matter what the sign is that it's coming from above it, the 5.
What's
It's
negative
not
6
gonna
plus
ma-
1?
Right,
Negative
but I mean,
5?
like, that isn't, it's not like the negative and negative mix, like, that's where I think I keep getting confused.
It is. It is exactly. You know it's got to be negative 6 and 1. I mean, you know it's got to be 6 and 1. Which one's got to be negative is the bigger one. Which means the smaller one is positive, or else it's going to add up to be negative 7.
Okay,
Yeah.
so if I got that, and now my next part, I get confused with too many parentheses.
Okay, cool.
I get crazy.
Not
with
cool, but let's see.
parentheses.
All right. These parentheses I need because of the 2.
Right,
So I got 2 parentheses.
right.
Now forget about that. Just work on what you got on the inside. What comes out of these 2?
3x.
3x.
Okay, that's what I did.
X
And then
minus
x minus 1. Oh.
X minus 2.
Right? Plus the only thing that comes out of here
1.
is 1. If nothing comes out, 1 comes out. Right? 1 always comes out.
Oh, because I switched it. I had it like that, and I'm like, maybe if I switch them this way.
So these parentheses
So I
are just
switched
because
it
of
and
the
then-
2. These parentheses are from the grouping step. And I agree. I mean, again, with the more parentheses that come into play, it's like hard to keep track. But even if you left that last dude off, even if you did, I don't care. There it is again. Like 18 puberties in one day. It's a lot to go through. Even if you forget that guy, I don't care. Right? I mean, what's the last step going to be? The last step's basically going to round it all up anyway. The 2 comes for the ride. What comes out of here? X minus 2, and you get 3x plus 1. Shlabang. Right?
Aren't you supposed to, when the 2 carries over like that, aren't you supposed to put a bracket or something?
No.
Okay.
You could put a bracket here because you got multiple parentheses. That would be awesome because I've actually never seen a student voluntarily use.
Yeah, that's
Brackets.
the way I was.
But that's awesome. That's exactly what they're there for. So you can keep track of
Yeah, we can use
the
them.
different levels. Because you can imagine like having something like x minus 7 plus 2. My God. Right? Okay. Whenever I see that thing about onions, I like to cook, so I was thinking about the different layers of an onion. Parfait. No. Shrek? No. Yeah.
Can you do number 30 from that same page?
Is that the final answer?
Yeah, that's it. How do you know you're done?
Okay.
No, that's how you know you're right or on the right track. How do you know you're done? Yeah, none of this can go any further, and it's just 2 times this times that. So I know I'm done, because nothing goes any further, and I only have multiplication in between my players here, right? Okay. So, sorry, which one was 30?
30.
Oh, yeah, let's go.
What is the 3x plus the last one? Or the last one?
I know, but that's where it came from.
Oh, okay.
When you take this out, you're left with 3x
Yeah.
plus 1.
So once you take out the GCF, that just pretty much just stays by itself the whole time.
Yeah, whatever
to
you
the final.
get done just comes for the ride. And if you think about it, we remember back in the day when you had to do prime factorization?
Yeah.
And you might do something like this, 2 times 34, and then 2 times 17. That 2 comes for the ride, right?
Oh, yeah.
Whatever you get done still has to be there at the end. It can't just stay up there somewhere. Your last statement has to be exactly this. If you multiply this out, you get this. If the 2's not there, you don't. Period. So anything that comes out, it's got to stay there through all the way to the bottom. Now, real quick, just to give you an option. I'm not forgetting about number 30, by the way. We'll do it. Right on this step, when you take a 2 out and you get here, you can do this 2 and then work on this on the side. If you really, really need to. Do this grouping, blah, 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 and then throw that back in. You can always take a piece of a problem, work on it, and then put it back in. Right? Unless you're one of my exceptionally messy people. You got to be careful. You got to be a little organized to do this. But there's nothing wrong with that.
Can we do the 6 times 4 like we did the first folder?
Yeah, oh hell yeah. You can do the 6 times 4, blah, 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 but you're going to end up with you might end up with 2x minus 4, 3x plus 1. And see this? 2 would come out and it would be the same thing. You would just end up with the 2 still in there because you didn't take it out. But it would just come out at the end. So there's that trade-off. Take it out but don't forget the dude. Or leave them in and deal with the little bit bigger numbers. So it's whatever way you want to do it. Okay. So number 30 is disgusting because of the numbers. You guys got this here? Okay. So 30 says... Is there a GCF? Damn. All right, so what do you have to do? Yeah. 35 times 44 is something.
1,540.
Do it again.
1,540.
1540? Negative 1540. So I need 2 factors of that. And we all know the factors of 1540. that add up to be
Definitely won't have that, definitely don't.
57.
I'm done.
I don't know.
Yes, forever.
So this is a really good example of a place where I'd rather just start with this. So for example, there's a silly place to start. They have to be different signs, right? Because they have to multiply by negative. Okay, so I could do something like negative 60 and 3. That would make negative 57. But that only multiplies out to be negative 180. That's no good. Way too small. Damn. So then where can I go from there? I can go up by 10 maybe. Negative 70 and 13. You guys kind of with me? That still makes 57 when you add those together. Right? Okay. But what's negative 70 times 13?
19.
Yeah, I'm getting closer now, right? So if I go to negative 80 and 23, that still makes negative 57 when you add them. Yeah, that probably is too much. That's 60. That's at least 16. That's 1840.
Yeah.
So I've gone too far. So now I know it's in between here. But see, that's a game I could play pretty easy. Much easier game than what goes into 1540.
Well, that's what I was doing. Like, I was taking like 1540 divided by like 20.
Okay.
That's stupid.
No, it's not. Nothing wrong with that.
I don't know. I don't know. Like, my brain doesn't think right away. Like,
No, it's fine.
that's what I'm
So you
doing.
certainly could take 1540, divide it by 20, and see whatever it goes into, and then see if it adds up to 57. If not, try to divide it by, I don't know, 21, 22, 20, whatever. Whatever you're thinking about. Right? Divide it by 30, divide it by, you know. So. This just to me, what's a good word there? Closes in on it quicker. And I always have in my mind that Price is Right game. Higher, lower, higher. Of course, some of you guys are like, Price is Right, I've heard of that. Never seen that thing. Did you think with Drew Carey? So then you just try somewhere in the middle, so I would go ahead and try like negative 75 maybe, right? Negative 75 and 18 make 57. And real quick, all I'm doing here, now watch. Negative 60 and 3 obviously make negative 57 when you add those. I mean, that's cool. When I go up by 10, I go up by 10. I went up by 10, I went up by 10. From here to here, I went up by 5, so I go up by 5. I mean, at that point, I don't look at 75 and 18 and automatically know it's 57. Not even me. I got to think for a second. Okay, it's 57. So, but I just base it off of what I know works. You know, so I mean, it's the more comfortable you are with numbers in general, the easier any factoring method's going to be. And you can make any factoring method I've shown you easier for yourself based on how you look at numbers. What's negative 75 times 18?
1350.
Closer. So it's got to be in between 75 and 80. I mean, so we're zooming in on that a little bit. And I also know that it's got to end in a 0. So 76 and 19 are no good. 77 and 20, that's it. Right? So it's 77 and 20 that I have to break the middle term up into and group it from there. So hey, what the hell? You said 20, didn't you? So you got it. Kick ass. Nothing wrong with
It
that.
didn't make sense to me when I saw it. I picked my calculator still.
Huh?
I did like, I don't know what the hell.
Yeah, you did fine.
Oh yeah, it gave me 77.
And it adds up to negative 57.
Oh, but then I have to backtrack and make sure that it adds up.
Yep.
Okay.
Okay. All right. So anything else from the homework?
Remember, my problem is seeing how far to break it down. Because on 6-4, I'm number 90 and 80. And it's after I get my little solution if I break it down anymore. I'm not sure if you can or not. So
we got other one here?
No.
You guys good? We didn't do that problem, by the way. But it did set it up so you can do it. Looking at 80. I like 80.
That's
What?
6-4.
6-4, yeah. What form is that in? Squares. It's got 2 terms. It can only be squares or cubes. And I can cut everything in half, so it's squares. No GCF. Yeah, exactly. Cut x4 in half, cut 16 in half, put plus or minus,
And that's it,
and
right?
you're not done.
You're not done.
Hell no.
Okay, that's where I'm at then. Exactly.
All right, so why was I able to factor this? Because it's a difference of squares. So which one of these is also a difference of squares? No, that's a sum of squares. I can't do that.
Minus.
That can be cut in half still, right?
Right.
This guy comes for the ride.
Okay.
Can't factor a sum of squares. I can't.
Okay.
What do you mean?
Why can't I factor a difference of squares? Because the only way to make the middle term cancel is to have two things that have opposite signs, right? If they have opposite signs, what will they multiply to be? Negative. So I can't handle if there's a plus there. Right?
Right.
So if you think that that's x plus 2, you're wrong, because you get 2x, I get 4x in the middle. I'm not supposed to have a middle term. These signs have to be different in order for the middle term to cancel. Are you guys with me? The whole thing with difference of squares and stuff is there's only two terms because the middle term cancel. The only way to make the middle term cancel is if they're opposite signs. If they're opposite signs, they multiply to be negative. Therefore, I can't do a sum of squares. I can only do a difference of squares.
Should you start off with like x to the fourth plus 16 or just that?
Then you stop dead right there. If that would have been a plus there, this would have been a great problem. But you just stop. Say prime. Leave me alone. Right? But this guy goes further. And we basically just did it there. X plus 2x minus 2.
And then that's right.
And then that's right.
And so number 90 is really similar to that.
90 is the same kind of thing, except the first step is GCF, I think, right? Yeah. First step is GCF.
Okay, then I did that one wrong.
So 90 is not the same. You're right.
I put 49x and 49x. and
Oh, but 49 times 49 is not 98.
Oh.
You got to think of it in terms of multiplication. So see, a GCF comes out, and then it makes it possible.
Okay.
Yeah.
Thank you.
Sure.
So you said the plus 16 you went to really work is for prime?
Yeah, if that was a plus, you would be done. The same way that that's done, if that was a plus, it would have been done from the beginning. Right? So anytime there's a higher power than 2, when you break it up, there's a chance that something can still go further. Are you with me? If that was a squared, I end up with x to the first. I can't break that up anymore. I only got 1x. How can I break it up? So if I start with 4 x's, I break it up. I got 2x. I can maybe go further. But then you have an interesting thing about this number. This number would have to be able to be cut in half twice. And you can do that, of course. Because 16 you can break in 4 parts. 2, 2, 2, 2. So of course you can cut it in half twice. Another number you can do that with is 81. 81 is 9 times 9, and 9 is 3 times 3. You can cut it in half. So if I made it x to the 4th minus 81, it would have been the same kind of problem, just with 3s and 9s running around, right? Maybe. I'm not sure. Yeah.
For the center, x plus 2, is there some kind of rule about
No.
the center of them having to be exactly half of the first power? Like this x squared plus 4, and then the next one is x plus 2.
Just because I took this and I rewrote it in its parts. There's no general rule. It's
Does
just
that
what.
happen at all?
Hmm?
Does that happen across the board in all problems?
If I had a problem just like this, where I put like an 81 there or something, then sure. If you happen to order it like this. There's nothing that says that has to be in the middle, for example, right? Yeah, I could have written this the other way. And then that would have been over there. I mean, what matters here is that you do something, and then you look at what you got and see if you can do anything else to any piece of it. I can't do anything more with that piece, it stays there. I can do something with that piece, I do it. I'm not going to try to generalize a rule that only works for a specific type of factoring, and it might not even be what's there. All that matters is that's a type of factoring I can do something. I mean, it's a form I can do something with. Right? Cool. So there's a lot of rules you can make that aren't really useful rules. Because you don't need them. You just need to understand the idea of just do more with it if you can. That will get you through this problem, right? So you do that. There's something you can do more with, so you do more with it. And the thing that you can't comes for the ride. Maybe. Yeah, Jim.
Can you find a GCF with two different numbers with two different letters behind it?
Yeah.
Something X and something Y.
Oh, hell yeah.
I thought those were
4x minus 8y.
I thought you
What's the GCF?
separate.
4. Because we're talking about multiplication here. It's not a like terms idea. I can't combine those, but I can strip something off of each of them. I can take a 4 off of each of them, right? If they were the same, if they were 4x minus 8x, I wouldn't even talk about factoring that thing. I would just combine them. Then there'd be no point to talk about factoring, right? So when I factor, I assume all my like terms have been put together. I see there's no like term, so then maybe I can factor something. So in this case, sure, I can take a 4 out. I'll go for that. I still can't put the inside together, right? Still not like terms. That's it. So I took the 4 out of there and a 4 out of there. I'm left with those two things. Okay? Yeah.
How about number 50 on 62?
Oh, this guy. How much power do I have? 50.
Seems like it's really easy, but I don't know. I got confused.
Take a look at that. Section 62, number 50. While I set up life support for camera. Oh. Okay. So, number, what was it, 50? Yeah. So remember what I said about the first number being negative?
Yeah, I can take out like a -1 or something. Um, 6, 2.
Oh, a squared. This one here, right? Number 50? So yeah, the first thing I do is take a negative, how many a's?
2.
Yeah, because there's no numbers that can come out. So everything changes sign now, so 4 a's, I took 2, so there's 2
Oh,
left.
now everything changes signs because you took that
Take a negative out. Yeah.
But that's what I was confused like with now with the positive at the end. How
It
does
becomes
negative?
negative.
Wait, do you have to take the negative?
You don't have to, but trust me, you so
Oh.
want to.
So if there was nothing, if there was no like term, if there was nothing you could take out, you would just take the -1 to get rid of
Yeah.
the negative?
Yeah.
If nothing else. If
And
A
let me
was-
show you, I mean, if I have this, let me see if I can, that won't even work. I mean, it just makes it so difficult. You need two numbers that multiply -4 that add to be 4. Right? And what would those be?
2 and -2.
But they don't add to be +4, do they? I mean, but if you take a negative out, now I see I need two numbers that multiply by 4 add to be -4. That's -2 and -2. I mean, that's a real quick little example about if you have that negative in there, you actually have to take it into account. Negative times -4 is +4. I mean, oh my God. No, I don't want to do that because this is the first number of 1. No, it's a -1. Shit, I got to take it into account. So that's one big reason why I take the damn negative out of the way. Right? Make that first number a 1. If you force the issue, your signs will almost always come out wrong. You'll have the wrong negative in the wrong place, whatever. Take that negative out of the way, then you'll be fine. So what happens here? Yeah, plus A minus 132. So now I just have to find two numbers that multiply to be negative 132 and add to be 1. Yeah, 11 and 12. Cool. Now how do you get that out?
Yeah,
You
how
just
the hell
start
did you get that?
multiplying.
Like, I cannot, that's
Well,
the biggest, hardest part for me.
Most of us should know
I mean, I get, like, I can figure it out.
our
My brain's
12
not
times tables, up to 12 times 12, but a lot of us always forget the poor 11. And the way to see that 11 goes into like a 3-digit number, like especially in the hundreds, is it goes into 154, it goes into 121, right? 11 times 11 is 121. So it's going to be, 121, 132. See the pattern?
Yeah.
Like 132, 143, right?
I squared the number. and then worked it out.
Oh, square rooted it?
Yeah, I squared it.
Not a bad idea because they have to be offset by 1.
Yeah, exactly.
So if you square root it, you get some ugly decimal, but it's close to the whole number. It's got to be offset by 1.
Yeah, that's how I figured
So another way to do it is just to say, okay, what adds up to be 1? 10, negative 10 and 11. Well, that's negative 110. It's not negative 132. Make it a little bit, negative 11 and 12. I got it. Cool. You gotta, at the most basic level,
It's just knowing your own.
you just, well, it's not even that really. It's just breaking 132 up, or taking 132 divided by 8, divided by 9, divided by 10. It's just like I was saying, though, the more comfortable you are with numbers, the more you can shortcut that whole thing. You can get somewhere quicker. But just realizing that they're off by 1 is huge. Then you just start doing 9 times 8, 10 times 9, 11 times 10, 12 times 11. You got it. Right? You got to use all the information this problem gives you. And this problem gives you a lot of information. They got to add to 1. Which means they actually have to be 1 apart.
Oh, right, okay.
So then use that information. So that you're not completely floundering. You got an idea of what they have to be in relation to each other. Is there any other thing, Jerry?
We do number 56 times 4.
Oh yeah, okay. Real quick before let me build up that one a second here. Where's that? 56, right? Got this here. Is this is that a difference of squares?
No.
You can take the negative out, right?
Not even that. It is. I just rewrite x squared minus 4.
Yeah.
It is a difference. It's just that they've rewritten it, they being me, so that the negative's first. All right. So with that in mind, the first thing I do with this is I turn it around. All right. So it is a difference. Is it a difference of squares? Because the 12
Yeah, it doesn't break.
is not a square.
So there's no difference.
Yeah. So it's not. It's not a difference of squares because it's not a difference. Break that sentence down. It's not a difference of squares because one of these things is not a square. Right? One of these things is not one.
Sesame Street.
Yeah, I know. I don't know where that came from.
What section is this? Where's that?
That was 6-4. Okay. Yeah.
Oh, is that it for 56?
Is that it?
Yeah.
Mm-hmm.
Yeah. It just said identify if it's a difference of squares.
Yes, that's it.
And you say no.
So you have to-
Even if it is, you don't have to do it. You say yes. So all I did was say identify if it's a difference of squares. There's no thing there. Okay.
The answer's no.
Yeah. No. What am I looking at? 63?
Yeah, honestly.
Alright, so this is a lot like one we just did. What's the GCF? C squared, but I also want to get a negative. Good. So then I end up with 14t squared minus 19t minus 3. And now you do your whole 14 times negative 3. So is it after that?
I think that's what it is. I didn't change the sign on the
Okay.
I'm not getting the same answer as the book. For some reason, it's saying it's 37.
Well, let's try it out. So 14 times negative 3 is negative 42. Any factors that make 19?
21, or negative 21.
Yeah, and real quick, the last problem we had where the middle number is 1, so we were trying to divide it. Somebody said square root it, which is a good idea because it kind of like cuts it in half and you get close to the answer. Here, the middle number is big. It's a big difference. So I want to try to, one way I can do is divide that by small numbers. So it'll be a small times a big. So the difference will be big. So divide that by 2, I get 2 and 21. Sure enough, it makes 19 negative as long as 21 is negative. So this comes for the ride. And I can break up my negative 19t as... Good, I'll put the negative first. I love it. Plus 2t minus 3. And then group... So the same so far? What comes out of these two? 7t. Oh, you can make the bracket if you want to. If you want to. 7t comes out. 2t minus 3. Thank goodness. What comes out of there? 1. Oops.
Where did the 1 come from?
Because can anything come out of 2t minus 3? No, so I just can take a 1 out. And the reason I do that is it's so much easier now to see the next step. If you can't take anything out, you're wrong. You can always take 1 out. Just why would you do it? Well, here's one situation where actually taking the 1 out makes it easier to see what the next step is.
Oh, because if that was nothing, like the 7t, I know that I would
Because people do this on the next step. If you don't put that down there, I always get this as an answer. And that doesn't make any damn sense.
Okay, so I know.
That times that is that. Where'd that guy go? But if I put that 1 there explicitly, I can see that I have 7t plus 1. And of course on the outside I've got my, I don't need all this shit anymore. Negative t squared.
And that was just out of curiosity. How is it that you know that it's always, is it always a plus that goes in between two boxes?
No, definitely not. It was just a plus because I took out a positive 1. If this would have been minus 2t plus 3, I would have taken out a negative 1. It would have been a minus there. If I take a minus out, it's a minus there. If I don't, it's a positive. That's all.
So, because I'm not doing the negative part in the beginning, and my answer is still the same, but it's t2 times 7t plus 1 times negative 2t plus 3.
Yeah, it's the same thing.
It's the same
And that's
thing.
fine. That's not wrong. Just for me, it would have been a little bit harder. Well, not really.
It just makes
The
sense.
grouping kind of makes everything go in the right place.
It doesn't seem like
But you don't have to take a negative out. It's just my personal preference. I think it makes it easier, and that could just be because of me. Maybe it doesn't matter to you. That's fine. You can leave the negative in there. Yeah.
Hey, I put the the guys that matched right next to each other, so I put 2 and 14 together and 21 and 3 together.
Okay.
But then, like, when I get down, I get 17 minus 1, 17 plus 1, and then -3 and -2. So I pull out pull out one of the signs, but then I get.
You can't pull anything out. So you did this. Let me just forget about the negative t squared for a second. You got this here, right?
Yeah.
Okay.
Yeah.
So then here 2t comes out,
Yeah.
and here a -3 comes out.
I think. Yeah.
So both of these become positive. Take a negative out, they both have to change signs. And these are the same thing. Here I got my 2t minus 3 on the inside, you got your 2t minus 3 on the outside. I don't care, the next step they're both going to agree. Right? So I see you comparing it to this. What's more important is you understand what I did here. It's not a minus there. Because when you take a -3 out, they both have to change signs.
No, that's not where I messed up. I messed up at the 14. I put 14.2 minus 2t.
Oh, okay, well it's got to be, I just erased that part, but it's got to be -21 and 2.
Yeah, I think I just got mixed up.
If you do that wrong, then it's going to mess up later.
Yeah.
Oh, yeah.
You do 6.6 on a PVC?
Oh, yeah, okay. Uh, 56, right?
Yeah, 56 on 6.6.
5666. That's 2056 or something. Did I do 60? 56 on 66. Alright. 66. The really funny about this problem, I mean, here's one place I would certainly not do. I know it's not in 1 out there. What's the only way you can factor 2? 2 and 1. 2p and p, right? What's the only way you can factor q squared? Q and q, right? But does this work? What do I get when I check this out? Everything's got to be plus, doesn't it? Because everything's plus there. I get qp plus 2qp. Is that 1 p? No, it's not. So that one, as long as I wrote it down, right? I did. That one is prime. Yeah. There's no factors of 2 that add to be 1. Basically, is what's really going on.
If you want to do it, you said just say prime. And
you just say, yeah. You kind of cross out your work so I can see you tried something, and you just write prime. No. Yeah.
Did you do number 43 on the same section?
Yes, and this will be the last one I'm doing. We've got to get the new stuff there. So 43.
Okay, instead of 43, can you do 36?
Ah.
You can tell me how to do it. It has the 5 thing in it.
I understand. So which one?
36.
36. Oh. All right, real quick, guys. Now watch.
Is this new shit?
No, it's not.
We didn't do this yet.
There's no
though,
shit
in
here.
lecture, right?
We've done this.
There's all kinds of shit. You're always
We've
talking about
done
shit
this.
there.
Listen, haven't we done letters? How do you factor this? How do you factor AB plus B squared? How do you factor that? Take out a B. A plus B. How do you factor A? Let me show you some weird shit. A lambda plus lambda squared. Take out a lambda. A plus lambda. There's some Greek shit for you. Right? There's some more Greek shit for you. All that matters is that is a letter. That is a Greek letter. Right? So what do they both have?
2 pi r.
Yes, they have a 2, they have a pi, they have an r. Do you care that that's pi? Yes, apparently you do, but you don't care that it's pi. All you care about is they both have it. So, yeah, so what do you get? Yeah, 2? R. You took the pi away, took an R away, plus 1. Right, so, I mean, I've had colleagues that have done this, and I certainly won't do this besides what I'm just now going to do. 3 happy fish plus 4 happy fish squared. Hey, you factor in a square. But, I mean, I can put whatever symbols, oh yeah, I know, I can put whatever symbols I want in there. If they both have a box with a dot in the middle, I can take out a box with a dot in the middle, and I can take out a 4 here, right? And I got 1 plus 2 box with a dot in the middle. I mean, it's when you get down to it, numbers and letters are all just symbols. We know what those symbols represent when we're talking about A, B, and 3 and 2. Start throwing pi in there, we know what that kind of means, but we don't use it all the time. You start throwing boxes with dots in them, but the idea, math doesn't care what's in there. It doesn't care if you have Greek, Russian, boxes with dots in them. It doesn't care, right? The process is the same. So that's a good choice. All right. Woo. So 6-6. Very quick. There's nothing really new in there. 6-6 is a review of all factoring. It is a really good thing to do to get ready for that, for example. Right? Because you know I'm going to give you a quiz. There's going to be, it says factor the following. And they're all just going to be, so you have to, it's not going to be in order. Right? I'm not going to do grouping first and then surefire and then whatever. So you have to be able to identify what it is. That's exactly what this is all about. They just jumble up all the forms. This is perfect practice for what you have to be able to do. Identify what kind it is. Know how to factor that type. That's what this section's all about. Nothing new in this section. All right. So 6-7. That's new stuff. That's the end of that. So let me ask you a question. Let me see if I can just say this and not even write anything down. If I told you I have 2 numbers that multiply to be 8, can you tell me anything about those 2 numbers? Does one of them have to be 2?
Both have to be the same sign, right?
Does one of them have to be 8? No. They do both have to be the same sign. I like that. But you can't tell me anything about the value of either number, right? No, I don't even know if they're negative or positive. I just know that they both have to be the same thing. Are you guys kind of with me? So if I have 2 numbers that multiply to be any number except for one specific number, I can't identify what either one of them are. But if I have 2 numbers that multiply to be 0, what has got to be true about one of those things at least? The only way I can multiply to be 0 is if one of them's 0. You with me? So if I have 2 numbers, A times B equals 0. What must be true is A is 0 or B is 0. There's no getting away from it. But the minute we start doing this kind of thing, I get people get A, B equals 7. Well, A is 7 or B is 7. Yay. No, that's crap. Right? If they multiply to be 7, this could be 14 and this could be 1/2. This could be square root of 7, this could be square root of 7, to tell you honestly. I mean, there's a ton of things these things can be, but the minute it equals 0, then it's one of them's got to be 0. There's no escaping it, right? So what the hell's that got to do with, that has something to do with factoring somewhere. So here's the next level of this. If I had x plus 3 times x minus 4 equals 0. You must resist the temptation to FOIL that thing out. That's the last thing in the world you want to do. I have A times B is 0, A is 0, or B is 0. I have something times something else is 0. Either x plus 3 is 0, or x minus 4 is 0. Let's let you absorb that for a second. This is actually almost the most important thing you can do with factoring. The first most important little application you can do with factoring is finding zeros of things. So if I had a cost and a revenue. When you add those, I get profit, right? And I want to find the most important thing in business. Now, again, if I was out there, I'd be going to sleep because me and business don't get along. But the most important thing for a business to do is to find its break-even point and then say, well, obviously we want to do a little more than that. So we actually make some money, right? That would be finding a break-even point, setting it equal to 0. Where's our profit? 0, and then we want to go past that. You guys kind of with me? Okay. And then you solve each of these. So how do you solve this? Subtract 3, x is negative 3. Add 4, x is 4. Right? And we talked about my little experiment trying to hold the atoms up. Did we talk about that? Were some of you guys here for that? Remember that? Some of you guys are like, I tuned out. You start talking about freaking atoms and shit. But I wanted to try to find out where that whole, and it would really just boil down to an equation like this. I wanted to set something equal to 0 to find out where the spots were where it would bottom out. I wanted to put it here in the middle. So to solve that equation, try to factor it and solve it just like this. Right? Find where the locations of the well would be. Okay. Hopefully so you guys can see how they're not going to give it to you like this after the first couple problems. They're going to give it to you not factored yet. This is already factored. Yeah.
But if it equals 0, x equals...
If x is 4...
4, never mind. I was
yeah.
Okay, see it.
Cool. So some of you guys should probably be able to skip this step, which is fine. You can see negative 3 would make that 0. 4 would make that 0. That's your answers. Right? So what if I have something like this here? We'll do one more like this before we move on to the nifty stuff. Bless you.
Thank you.
Just got a problem with people lose an answer.
You distribute this?
No way. So the whole point of this section is, if it's equal to 0, you want to factor the other side. So you can see the parts. So see, this is factor A. I can see the parts, and I can do each part one at a time. That's already factored. I don't want to distribute it back through. It's going backwards. What do I know is got to be true about this or this? Either that is 0 or that is 0. This kicks ass. That's an answer. Right? But everybody forgets that. They see the 1x there and they're like, doesn't have anything with it. It can't. No, if x is 0, that's 0. If x is 0, what's this? If x is 0, 2 times 0 minus 11? Negative 11 times 0. So the whole thing's 0. There you go. So if x is 0, I of course make this thing 0. If this other guy is 0, then I don't care what he is, the whole thing is 0 again. So how do I solve this piece? Add 11. Divide by 2. So let's check it. Check. If I make x equal to 11 over 2, so I get 11 over 2 times twice 11 over 2 minus 11. Oops, check. What's twice 11 over 2? 11. What's 11 minus 11? 0. What's that times 0? 0. It's true. So the whole point of this is, if I make either piece of that 0, then of course the whole thing is 0, because it's multiplying. So what makes this piece 0? 11 halves. What makes this piece 0 is almost too easy. 0. What would you make x equal to make x equal 0? 0. Right? Then x is automatically 0.
But you're saying you would have to do all of that regardless, or you would just, if you just went with the 0 out there, you'd be fine. You don't have to do it for all other stuff.
What other stuff?
On the right.
You have to. That's how I got to the answer.
It's either 0 or 11 halves. There's 2 answers.
Yeah. 2 answers. 2 ways to make this thing equal 0. So real quick, look at this equation right here just for a second. Before we even factor this. See how x is everywhere? So if I make x 0, what do I get here? 0, don't I? If I get x 0, I get 0 squared minus 4 times, that's 0. So one answer is going to be 0. If I make x 4, what's 4 squared? Minus 4 times 4. So another answer is going to be 4. Now let's see what we get when we factor this. Can you always do this? Hell no. A lot of times it's going to be ugly. You're not going to be able to just look at it and go, 7. No, you can't do that. How do you factor this thing? Take an x out. I love it. So there's 2 ways to make this expression 0 because there's 2 parts to this expression. There's the x part, and there's the x minus 4 part. Say again?
Why wouldn't the second answer be 0 too? 4 times x squared is 16. Minus 4 times 4, which is 16.
So what do you have to make x to make this 4 times 4?
Right.
X has to be 4.
Right, and then, but the answer is 0.
No. If you make x 0, what do you get here? 0 squared minus 4 times 0 is 0. So both of those make that 0.
Oh, right, yeah, okay.
Because what makes this part 0? 0. What makes that part 0? 4. Right?
I thought you were saying that the answer would be 4.
One answer is 4.
But for x.
And the other answer is 0. They both work. Good.
So if you're saying there's 2 answers, does that mean if one of the answers you plug in 0 to both x's, and the other answer is you plug in 4 to both x's?
X can only have one value at a time. I can't say I want the first x to be this and the next x. No. X is something and then they all get replaced by it. Does that make sense?
Yeah.
If I have a single variable, it can only have one value at a time. I can't say I want the first XIC to be 7 and the next x to be 2 and then no, you can't do that. X has to be a single value at a time. X can be any damn thing, but it can only be one thing at a time. Is that cool? Okay. Yeah.
I don't even know how to ask this, but how do you know there's like only two answers? Like, could there be more?
I love it. You did great. What we learn eventually is the fact that there's a second power here. Tells me that there must be an overall 2 answers. Yeah. There's a lot more to that story because we only right now know real numbers. There are other things. So if I had a 5th power here, I must have 5 answers. Some of them might be not real. Right? So we'll only get a few answers in this class because we don't know the other kind of numbers. You with me? Cool. But that's a great question. It's because of that square. If I had a cube, I'd expect 3 answers.
Is one of them always 0?
No. I'm glad you said that. This is the danger of teaching. Remember, didn't we have that problem earlier? Where we had something like this? And one answer was 4 and the other answer was -3. No 0, right? Okay. So now, of course, you'll get something like this. Like what, Jeff? I don't know. And the biggest mistake I see, well, actually, I don't know how to generalize this mistake because there's a lot of different takes on it. But people start figuring it out from that. What do you have to do first before you can really see what makes it 0? You have to factor it. Now, some of the ones we've done so far were GCFs. Is this a GCF factorization? No, because there's nothing that they all have, right? So I can't take an x out because 12 doesn't have an x in it. So how do I factor this?
Probably negative.
So what 2 numbers work? They got to multiply to be. They have to multiply to be -12 and add to be -11. So I know that this factoring problem sits in another problem of its own. But if I have to factor something, I don't care what else is going on. I factor that. The process doesn't change. So it has to be -12, +1. Yeah. So either that's 0 or that is 0. So then x is 12 or x is negative 1. You can skip that step, sure. And I'll be fine with that. Because some of us can look at that and say, okay, what would I put in there to make it 0? 12. What would I add to 1 to make it 0? Negative 1. So but do this step if you need to really see it. Because the property, and I can't remember what this book calls it, but it's like the zero property rule. Here we go. The principle of zero products. I love it. Something times something is 0 means that the first thing is 0 or the second thing is 0, and then they can solve each of those equations. So it's kind of a trade-off. I have one ugly second-degree problem. Doing this makes it 2 nice first-degree problems. Sounds good. Yeah.
Wouldn't you carry down the x squared down to the next equation, and then couldn't you factor it even more because then you're left with the...
No, x squared is x times x.
Okay.
Yeah, so there's no higher power left. Cutting that bad boy in half. Yeah. Okay. So this just adds one step onto the end of a factor problem. Take each piece, equal it to 0. Right? The unfortunate thing is, everything in the world becomes 0 now. I'll ask somebody, factor this. And they'll say, okay, Jeff, no problem, there you go. All right, so x is 4, negative... Oh, what? Where did that come from? That's not an equation. How the hell did you get... Oh, John. That's not an equation. I can't get answers. All I can do is simplify that thing. I have to stop here. So be careful. I can only get answers when it's equal to something. Right? So don't make everything in the world 0. That's kind of a bleak outlook. Everything is 0. Some things I like 0. Right? Like my car loan. Okay. So really all I can do to you is put harder and harder factoring problems in there. And also they can do this. I need some numbers. Let's see. Yeah, that one. So what's wrong with this?
Terms on both sides.
I like it. Now, if that x squared was not there, how would I solve this equation? Get my x's together, divide by negative 5, right? I subtract the 2x. I leave the 24 there, wouldn't I? It's the fact that, remember, what did I just say is important? You have to be able to get your x's together on one side and your numbers on the other. It's what we've been saying the whole time about solving equations, right? Just go yes.
Yes.
Thank you. The minute I put a different power on the x, so now my x's, are they like terms? No, I can't get my x's together. I need another way to do this kind of problem. I need to set this thing equal to 0. So that when I have something that's not a first power on my variable, that's what tells me to make it equal to 0 and then try to factor. That's the trigger. If that wasn't there, I could just solve it like normal. If that's there, I need a new way to do this. So I move all this stuff over. I get it equal to 0. So I could use the 0 principle, whatever that, right? It's like every book has a different name for this thing. So move all that stuff over. So on this side I have 0. Good. On this side I get 5x. And then can I factor this? Yes. Cool. So what numbers work there? Yeah, 8 and 3. Which one's got to be negative? The bigger one. Good. So x minus 8 is 0, or x plus 3 is 0. X is 8, or x is negative 3.
Why isn't x negative 8? Then you get x minus 8.
I love it, because negative 8 minus 8 does not make 0. I need to make this 0, so it's got to be the opposite sign. I love it. That's why I can skip this step sometimes, because you just say to yourself, oh, it's just the opposite sign of that. It's got to be this guy's inverse, this guy's opposite. Okay, yeah.
When we had a x squared minus 16, and equal to x, could you add the 16 square or no? Is that possible?
If you have x squared minus 16 equals 0.
X squared minus 16 equals 0, because you have 16 to the side, and that equation.
We could the minute that we get to that point. We are at the point where we're factoring to solve these kind of problems. Yeah. Later it would be using radicals to solve this kind of problem. Yeah. But we're not into radicals yet. Okay. So what about this? Here's the most evil problem. Oh my god. Let's see. Make something that works. That'd be good. That's good. I'll just keep myself safe. This problem you have to work backwards a little bit. So I always look at this problem like some idiot factored too early. They didn't get it equal to 0 first. They left stuff over there. So what do I have to do here? I have to multiply it back out. Suck that stuff over and then refactor it. Right? So see if I made something that actually works. Yes, it should. Okay, let's find it. X squared minus 3x. So I have to work backwards a little bit. The whole point is to factor stuff. But when it doesn't equal 0, I've got to unfactor. I've got to multiply it back out and bring this stuff over. They factored it too early. So I've got to undo what they did. Equals x plus 5. Now move this stuff over. X squared minus 4x minus 5 equals 0. And thankfully that thing will factor. How do you factor this thing? Yeah, 1 and 5, right? It's the only way to really factor 5. Big one's got to be negative.
How'd you get 4?
I subtracted the x over, so negative 3 minus 1. Yeah.
Real quick, rather than start, you can't just subtract the x because it's x on the other side multiplied by.
Exactly. If you try to subtract the x and kill that guy, you can't because it's involved in I have to multiply before I can subtract. So that's why I just go ahead and distribute first and then move the stuff over so it can go right with its like terms. Is that cool? And then what's the last step here? Yeah, you can do this. X plus 1 is 0, so you get x equals negative 1. Or x plus 5 is 0, so you get x equals 5. All right. So some very interesting looks. I'll give you one out of the book to try out. Here's the evil one. Let's see. to protect some of you from yourself, can you say x plus 2 equals negative 18? Or x minus 7 equals negative 18? No. What's the only number you can put there that makes that work that way?
0.
0. Since this is not equal to 0, I have to multiply it back out, bring that, yeah, good. Just like we just did on that last problem. So try that out.
Can you FOIL?
Yep. Yep. Which is factored too early. Good. Now you got to make that 0. Yeah, now you factor it. See, so you got to be really careful. You understand the main idea here is if you get a product of two things equal to 0, first product or the second product, whatever, have to equal 0. If it's not equal to 0, you better multiply this back out, get that back over. Somebody factored too early, those crazy people. You got to have it equal to 0 to go further. So then, how do you factor this? Yeah, the only way, well, 2 and 2 won't make 5, but 4 and 1, as long as they're both negative. So x minus 4 is 0, or x minus 1 is 0. X is 4, or x is 1. And again, this is the first, most immediate practical application of factoring. Right? It allows me to solve an equation we could have never solved before. Yeah?
Why do you get x squared back 5x?
So when you FOIL it, you get x squared plus 2x minus 7x minus 14. 2x minus 7x is negative 5x.
I got it. Negative 7 plus 2 is positive 5.
No, the bigger one's negative. Okay. Cool, man. All right. So you guys want to take a break? Let's take a short break because we're going to leave a little early today. So come back at 2:30.